We will discuss about the spheres. The first, we take the curved surface area of a sphere. How to find the curved surface area of the sphere? First, take a ball, and for this ball, we have to roll the thread around it like this. If you roll the thread, then the ball will be like this. And just remove the thread from this ball. And before that, we have to find out the radius of this sphere. Suppose if the radius is 2 centimeters, then we have to draw the circles with the radius 2 centimeters and remove this thread from the sphere and just fill this thread like this. So this thread will be filled in 4 spheres. Just observe. So the area of one sphere is pi r square, and these 4 circles are having the same radius, so that their areas are equal. So we have 4 circles, that's why their area is 4 pi r square. This area and the curved surface area of this sphere both are equal. From this we can conclude that the curved surface area, that is nothing but CSA, is equal to 4 pi r square. And we take the hemisphere. Let us find out the curved surface area of the hemisphere. How to find out the curved surface area of the hemisphere? So for the hemisphere, the curved surface area will be half of the curved surface area of this sphere. So we have to make it half. Then what will happen? 4 pi r square, the half will be 2 pi r square. For the hemispheres, we have the total surface area also. So how to find out the total surface area? Just observe in this figure. So this is the curved surface area, and this white portion, that is also, if you cut the sphere, then we get the circle here, and its area is pi r square. So the total surface area is equal to, its curved surface area is 2 pi r square, and the area of the circle, this portion, is pi r square. So we have to add these two, we get 3 pi r square. And we will find out the volume of the sphere. Just take the sphere and find its center, and we have to divide this sphere into pyramids like this. If you arrange all these pyramids, we will get a approximate cuboid, not the exact shape, but we will get the cuboid in shape, so that its volume will be 4 by 3 pi r cube. This is the volume of the sphere. If you want to find out the volume of hemisphere, then what should we have to do? We have to make it half. So for the hemisphere, the volume is equal to 2 by 3 pi r cube. Let us take some examples. Let us discuss this question. A right circular cylinder just encloses a sphere of radius r. That means we have to take the cylinder first. In that cylinder, we have to take a sphere. Okay. And the radius of the sphere, and this is the radius, and the radius of the cylinder, both are equal. But from this figure, we can say that the height of the sphere is equal to height of the cylinder. What is the height of the cylinder? That is nothing but diameter of the sphere. Diameter of the sphere is equal to height of the cylinder. So from this we can write h is equal to 2r. Yes, we can find. First one, surface area of the sphere. So this is the direct question. So the surface area of the sphere is equal to, curved surface area is equal to 4 pi r square. The second one, curved surface area of the cylinder. So CSA of the cylinder is equal to perimeter of the base into height, that is 2 pi r into h. So we will substitute 2 pi r into h. What is h? H is 2r. So we get 4 pi r square. So from these two we can observe that curved surface area of the sphere and the cylinder, if the sphere is enclosed in a cylinder, both are equal. And we go through one more question in that, that is ratio of the areas obtained in first and second. So both are equal. The ratio will be 4 pi r square is to 4 pi r square, that is nothing but 1:1. From this we can say that both the curved surface areas are equal. And we take one more question. Example 11. A hemispherical bowl is made up of stone whose thickness is 5 centimeters. If the inner radius is 35 centimeters, find the total surface area of the bowl. Just observe the figure. So the bowl is in hemispherical shape. The inner radius is 35 centimeters. So from here to here it is 35 centimeters. And the thickness is also given. Thickness means the difference between the radii of the outer radius and the inner radius. So this is called the thickness. So this thickness is 5 centimeters. So the outer radius will be 35 plus 5, that is 40 centimeters. We will write here. Inner radius is equal to 35 centimeters and thickness is equal to 5 centimeters and outer radius is equal to 35 plus 5, that is equal to 40 centimeters. What should we have to find out? Find the total surface area. First we have to find out the curved surface area of the CSA of the outer part of the bowl. That will be 2 pi r square. So it will be 2 pi into r. What is r? Radius of the outer circle, that means outer sphere, that will be 40 centimeters. So we can write 40 square. So by simplification we get 2 pi into 1600, that is equal to 3200 pi square centimeters. And we will find out the curved surface area of the inner part of the bowl. That is equal to same 2 pi r square. So 2 pi into radius. The radius is 35. Inner radius is 35. So we can write 35 square. So it will become 2 pi into, it is 1225. So it will become 2450 pi centimeter square. And we have one more thing, that is annulus. Here we get two circles. In the top part of the bowl we have a portion like this. Just observe. So this is the portion. We have to find out this area. So It is called annulus or ring. So its area is equal to, outer circle area is pi r square. I would like to denote the outer circle radius as capital R minus the inner circle radius as small r. So pi r square minus pi r square. So I would like to take pi as common. So it will become r square minus r square. So I will substitute in it. Pi into capital R is 40 square minus 35 square. It will become 1600 minus 1225. So it is pi into 375. So this is 375 pi centimeter square. And now I would like to write the total surface area of the bowl. So we have to add all these three. So 3200 pi plus 2450 pi plus 375 pi. By adding these three together, we get the area in square centimeters. You have to find out like this. Thank you. The hollow sphere. Here the word hollow sphere. Hollow in the sense a sphere which has empty space inside of it. That means it should be like this. Nothing is inside of it. Only the curved surface area will be present in that sphere, in which the circus motor cyclist performs his stunts, has a diameter of 7 meters. Find the area available to the motorcyclist for riding. Just observe one thing here. Hollow sphere in which the circus motorcyclist perform his stunts. So I think most of the students have not been seeing this one. So I will show it.
The famous motorbiker is the Next, let's welcome Mr. Bai Jingwei.
Find the area available to the motorcyclist for riding. That means we have to find out the curved surface area of that sphere. So here we have the diameter, and from this we can find the radius, and after that we can find the surface area. Next we will discuss the next example, that is 14. A shot put is a metallic sphere of radius 4.9 centimeters. Here shot put. The shot put means it is a sphere which has no space inside the sphere. So this is fully filled with the iron. A shot put is a metallic sphere of radius 4.9 centimeters and the density has been given. The density is 7.8 grams per centimeter cube. So it means for this question we have to find out the volume. Here 1 centimeter cube weight is equal to 7.8 grams. So after finding the volume we have to find out the weight. Here the word mass and weight both are equal. So let us discuss one more question. Example 15. A hemispherical bowl has a radius of 3.5 centimeters. What would be the volume of water it would contain? Here, volume of water we have to find out. So, Already we have known that the volume of the sphere is equal to four by 3 pi r cube. But here it is the hemisphere. So the volume of hemisphere is equal to half of the volume of the sphere. So that is 2 by 3 pi r cube. So from this we can find the volume. Here the radius is equal to 3.5 centimeters. So by substituting this radius in the 2 by 3 pi r cube formula, we can get the volume. And we discuss one more question. The hemispherical dome of a building needs to be painted if the circumference of the base of the dome is 17.66 meters. Here the hemispherical dome of a building. So we have to draw the hemisphere first. Suppose it is the base of the hemisphere. The base is in the circular shape. So for this hemisphere, the base is in circular shape. So its circumference is given. So the circumference of the base of the dome is 17.6 meters. So circumference is equal to 17.6 meters. From this we can find the radius. The formula for the circumference is C is equal to 2 pi r. So by substituting the circumference, that is 17.6 in the place of circumference, 2 into pi is 22 by 7 into, we should find out the radius. So by simplification, 17.6 into 7 by 2 into 22 is equal to r. So 11 2s are 11 1s are 0.6, 2 into 0.8. This is radius is equal to 2.8 meters. And after getting this, we will go through the question again. The hemispherical dome of a building needs to be painted. It is to be painted if the circumference of the base is 17.6 meters. Find the cost of painting it if given the cost of painting is rupees 5 per 100 centimeters square. So we have to find out the curved surface area of the hemispherical dome. So we know the formula for the curved surface area of the dome, that is equal to CSA is equal to 2 pi r square. So from this we can find out the curved surface area, that is 2 into 22 by 7 into 2.8 square. So by simplification we get 49.28 centimeters square. Sorry, 14.28 meters square. And the cost of painting. Cost of painting 100 centimeters square is equal to 5 rupees. And for 49.28 centimeters square, how many rupees? That is 100 centimeters square is equal to 5 rupees. Actually here the curved surface area we got in meter square, so that we have to convert the cost in the form of meter square. So for 100 centimeters square it is 5 rupees. Then for 10,000 centimeters square, how many rupees? Why I have chosen this 10,000 centimeters square? I will show here. For 1 meter square, that is equal to 1 meter into 1 meter. So 1 meter means in centimeters, this is 100 centimeters. So 100 centimeters into 100 centimeters, which will become 10,000 centimeters square. So that I have chosen that. For 100 centimeters square it is 5 rupees. For 10,000 centimeters square it is more or less? More. So we get more by less into 5. So by simplification we get the amount in rupees, that is 500. So now again we can frame the question, that is for 1 meter square is equal it is 500 rupees. Then in our question we got 49.28 meter square is equal to how many rupees? For 1 meter square only it is 500. For 49.28 meter square it is more. So that among these two the more value is 14.28 by 1 into 500. So we get 24,640 rupees. So like this you have to finish all the sums from exercise 10.4.